Hi, I'm Eric Jennings, the CEO of Pinocchio, and I want to introduce you to my colleague, Jeremie Miller.
Hi, I want to show you something really cool. This is a tiny wireless computer for under $10 from last year. They're already under $5 this year, and they'll be under $1 soon. The Internet of Things is definitely here. The scary part is it's being built on a lot of old technology that is usually insecure and centralized by default. A group of us have been working on a couple of projects to try and make that a little bit better. The first one is Telehash. It's a secure mesh networking protocol designed to let these things talk to each other, always private, always distributed, peer-to-peer, as well as to be able to talk over the internet to phones and to servers. The next part is microtransactions. What better way to unlock the value of a bunch of embedded sensors than to let them transact with each other, to let your phone transact with them when it's near them, to let servers transact with them when they want to pull data from them, to let them buy and sell data, and to be able to use the blockchain to transact and record all of that data. So I'm going to let Eric talk a little bit more about these projects, and he'll have some links for you at the end. I'm really excited to be in this space, and I think the future is going to be amazing. Thanks.
So, as Jeremie mentioned, we're working on a new platform called Filament. And this product is focused specifically on the industrial Internet of Things. Specifically industrial, meaning that we're not focusing on home automation or wearables. It's very much for the industrial and commercial space, which we feel like is vastly underserved right now in the IoT world. It brings the company's legacy equipment and infrastructure online. It increases efficiency, and Filament helps companies become smart and connected. That's a little bit of background about us, but why I want to share with you how we're approaching this platform and why we think it's so critically important to have a decentralized Internet of Things. Some of us remember the world, what the world looked like before the internet, where people would communicate, but at high friction. Communication was expensive. As we now know, less friction in communication leads to entirely new ways for humans to interact with the world. Today, embedded hardware inside of machines and equipment is most like technology of the 1980s, where personal computer revolution had occurred, but the internet hadn't yet publicly emerged. But what if machines had as little friction communicating as we humans do today? What new opportunities or even new markets would emerge? Hardware, especially sensors and radios, are getting so inexpensive, as Jeremie mentioned, that they can be embedded everywhere. Battery technology like lithium polymer gives us the power density we've needed to have devices run years on a single charge. Chris Anderson of 3D Robotics refers to this phenomenon of cheap, powerful hardware as the peace dividend of the smartphone wars. And he's right. Now is the time when devices become smart and connected. So why us? Why can't we just leave this up to equipment manufacturers to build into their existing infrastructure and products? We could, but large corporations like GE, Caterpillar, and Ford Motor Company will be left on their own to decide how to implement this new world of smart, connected devices. And guess who their influences will be? Companies like Facebook and Google, where walled gardens are the norm. Despite the size of these tech giants, I argue that there is more value to be gained by going decentralized than by remaining siloed. And let me give you an example. Jeremie, who you saw in the video earlier, has an interesting story from back when he was working on Jabber. It was an instant messaging product, and back then, AOL was the king of instant messaging with a product called AIM. You may remember this. AIM had the majority of the market share back then. Jabber developed a protocol to break the back of AOL by making a federated instant messaging platform where anyone could run their own chat server. And it succeeded. As of 2011, AIM has less than 1% market share, while Jabber protocol is used today by over 1 billion people daily in apps like Google Chat and Facebook Messenger. But a lesson was learned. Federation is great, but federation leads to consolidation over time. Sorry. The problem with that is that people like Google and Facebook end up coming back together as single oligopolies, and what that ends up doing is causing us to have to get back to the core again and decentralize everything all over. So a small group of us are setting out on developing a software stack that gives embedded devices the autonomy to interact directly with each other. No federation, no silos. It's audacious, to be sure. We absolutely see this as the future of the Internet of Things. Between leveraging the things we've learned from Jabber and with recent developments in distributed consensus algorithms, like the blockchain, we're setting out to make this a reality today. So what does this decentralized software stack look like? First, when we say decentralized, you have to put forth a mindset of no central servers required. How do we make this work without a central authority? By focusing on 4 main areas: device identity, secure communication, smart contracts, and microtransactions. First, devices must be able to coordinate with each other in a trustless environment. This turns out to be a hard problem without a central authority to guarantee the identity of each device. But using a blockchain, a manufacturer would register this device, giving it a unique identity online throughout its lifetime. Support and warranty needs can be used to identify this for servicing, and more importantly, devices can directly discover other devices through this blockchain identity. Now this device has an online identity in a completely decentralized manner that's verifiable and permanent. Once a device is identifiable online, securely communicating with it becomes the next challenge. Embedded devices have a very wide range of computing and memory available, so a protocol is needed to provide an encrypted device-to-device network connection. It must be secure with perfect forward secrecy and industry-vetted cipher suites. It must also be usable across many types of networks, from Bluetooth to Wi-Fi, cellular, even to gigabit Ethernet. It must also be able to traverse private networks. This protocol exists today. It's called Telehash. It's open source. It has a strong community with applications already built on it. Jeremie, who you saw earlier, has been at work on Telehash for several years. You could say it's emerged as a next generation of Jabber and will be for device communication as Jabber was for human communication. It's now in version 3 and is ready to be used for secure device-to-device communication today. You've heard a little bit about smart contracts today, and it also applies in the Internet of Things world. So once a device can be discovered, and once a secure communication channel can be made with it, how do devices interact in an inherently trustless environment? Contractual agreements between devices become necessary to prohibit unauthorized access, to allow privileged access, and when appropriate, even transact with each other. And this is done with a concept called smart contracts, implemented in software running directly on the device. Smart contracts could be simple agreements of data access, of controlling the device or the machine that device is connected to, or even financial agreements involving payment for the access to the device. It's important to point out that smart contracts in our world run directly on the device themselves and accept or decline access from others based on contractual terms. We're using a suite of standards called JavaScript Object Signing and Encryption, JOSE, to implement these contracts on the embedded devices themselves due to the inherent nature of the ease of use and the lightweight aspects of JOSE. Once these 3 concepts are in place, we have microtransactions, and this is how devices would actually issue payments to each other. Devices need to have a way to exchange value, but it's often very small amounts. Unfortunately, for us, existing blockchain micropayment support still has some limitations that make it difficult for small embedded devices to participate. We've established a very early draft of an alternative means for blockchain microtransactions called Penny Bank. Penny Bank enables embedded devices to exchange very small amounts of value directly with each other, online or offline, without excessive transaction fees or requiring heavy blockchain processing. With these 4 concepts implemented, devices can now not only discover and interact with each other, but they can transact value as well in a completely decentralized manner. This is the future of the Internet of Things that we want to see, and we're working hard to build. So what does the future look like with this approach? A friend of ours, John Cohn, and his research group at IBM have been working on a similar vision with an idea they call Adept. They've come up with some interesting use cases that very clearly describe what this decentralized future looks like. I'd like to share a couple of those with you. Take the lowly washing machine. You may have heard this from CES. I'm happy to cover it again. It's a boring, utilitarian machine we often forget about, except for when we're all out of clothes. But how would this washing machine operate in a decentralized manner? Let's take reordering consumables as an example. So let's talk about the detergent that goes in these. Modern washing machines, like the one you see here, already has sensors in it that detect detergent levels. And what happens when the detergent runs out? Well, in the decentralized future, the washing machine contains a list of detergent vendors, perhaps listed in the blockchain. It requests a reorder, makes a payment to the vendor, and lets the owner know about that order. On the vendor side, the retailer is paid through the blockchain, perhaps Bitcoin or Ethereum, fulfills the order, and communicates the delivery details back to the washing machine. Once the order is confirmed, the machine's owner receives a confirmation message from the washing machine with delivery details on her phone. Another example is where machines automatically request repair services. Washing machines already have sensors and analytics to monitor their performance. And in this decentralized future, devices like these store their identity in the blockchain and additional warranty details, perhaps. When the washing machine breaks, it would negotiate a service repair on its own by accessing its own warranty information and negotiating with the vendor to arrange a time to come and replace the part. It's important to note, a very important fact in both of these examples is that they're both three-party systems, meaning there's a device owner, there's a vendor, and there's the device itself. The machine becomes a participant in the marketplace just like people do today. In this future, machines have the ability to request replenishment or service on their own, and they communicate directly with humans and with other machines. They become autonomous agents, not isolated equipment. Machines become smart and connected, just like we humans did when we connected our first Hayes modems to our personal computers. And we know how amazing that turned out to be. This is the real promise of the Internet of Things. It's not embedded sensors, it's not smart contracts, it's not microtransactions, and it's not secure networking. It's all of these things together that will usher in a future free from silos, with machines and equipment bringing value to our lives. When we connect people and devices together, not separate them into walled gardens. If you're interested in learning more, I'm happy to chat with any of you during the break or afterwards, or visit the following links of some of the technologies we've mentioned today. Thanks so much.